In this video, I will show you how to solve a system of conic equations. For example, in this system of equations, the top equation is a parabola. I know this because only one variable is squared. The lower equation is not a conic section, it's just a line. Nothing is squared, so I know it's a line. So we're dealing with a parabola and a line, and we are trying to find the points of intersection. So when you're solving a system, your two main tools are substitution and elimination. It's really your choice which one of those you want to do. I could do either one for this problem. I'm going to choose substitution. Whenever I do substitution, I like to write the problems side by side at the beginning. It just helps me keep my work nice and organized. For substitution, you want to get one of the variables by itself. So I think I will simply add y to both sides. So that will give me x equals y plus 1. So now that I have one variable by itself, I can do the substitution. So I can just take this y plus 1 and substitute it for x in the other equation. So if I do that, this equation will become y plus 1 squared minus 3y minus 3 is equal to 0. Y plus 1 squared is y plus 1 times y plus 1 minus 3y minus 3 equals 0. I'm going to multiply these binomials together, and I will get y squared plus 2y plus 1 minus 3y minus 3 is equal to 0. These are like terms. So I now have y squared minus y, put those together. These are like terms as well, so that's minus 2 is equal to 0. This is likely factorable, so let's try. Y squared is y times y. 2 is 1 times 2. If I make this one positive and this one negative, the inner and the outer will make negative 1y. So this is factored correctly. We can find solutions by setting each factor equal to 0. Subtracting 1 from both sides, we have y equals negative 1. Adding 2 to both sides, we have y equals 2. So, in terms of the solutions, the solution set, here's what I have so far. These are both y values. So that means I have something comma negative 1, and I have something comma 2. I have y values, but I still need the x values that go with them. So I will get those x values by using the other equation. So we have these two y values. I'm going to substitute each one in and see what I get for x. So let's start by letting y equal negative 1. Okay, that's the first y value. If I do that, then this equation becomes x equals negative 1 plus 1. So x is equal to 0. So that gives me a solution. 0 comma negative 1. Now let's let y equal 2, the other y value that we have. Then this equation becomes x equals 2 plus 1. So x is equal to 3. So that gives me another solution. 3 comma 2. So this should be the final solution set. Let's go ahead and take a peek at Desmos.com and see how the parabola and line intersect at these 2 points. So here we have the parabola and line that we were working with, and we can see that they intersect at these 2 points, 0, -1 and 3, 2, which are the same 2 points we found solving the equation by hand. Let's take a look at number 6. The first equation is a hyperbola. The second equation is also a hyperbola. All right, hyperbolas are those conic sections that go like this, or sometimes they go like this. Okay, the way I know this is a hyperbola, both of them, erase, is because the x squared and the y squared, one is positive and one is negative. Whenever that happens, you know you're looking at a hyperbola. When you want to solve a system, our choices are substitution or elimination. Elimination would really work best for this problem. For elimination, we want opposites that cancel, and it's already set up that way. The x squared and negative x squared, and we have y squared and negative y squared. So we already have opposites that cancel, so we might as well do it. So if I combine like terms, the x squared goes away, and the y squared goes away. So that leaves 4x and minus 3x. If I put those together, that's just going to give me x. And then I've got negative 4 and 3, so that's negative 1. Okay, so I've got x minus 1 and then equals 0. So I can easily solve this and get x equals 1. Okay, so that means that in terms of a solution set, so far I have 1 comma something. I just need the y value that goes with this x value. The way I will find a y value is by substituting x back into one of these original equations and see what I get. So we will let x equal 1. All right, I'm going to use the first equation, but everywhere I see an x, I'm going to put a 1. So that means I'm going to have 1 squared minus y squared plus 4 times 1, all right, I'm right here, minus 4 is equal to 0. So that's going to be 1 minus y squared plus 4 minus 4 is equal to 0. These cancel each other out, so I have 1 minus y squared is equal to 0. Adding y squared to both sides gives me 1 is equal to y squared. Taking the square root of both sides, I will have y is equal to plus or minus 1. Don't forget to put plus or minus whenever you take the square root of both sides. So because I have two y values, I'm actually going to have to write my original x value twice. So I will have 1 comma something, and I will write another 1 comma something. So I have a place to put both of my y values. So I have y values of positive 1 and negative 1. So this should be my solution set. Now let's graph these two hyperbolas in Desmos.com and see how they meet at these 2 points. Alright, so here we have the two hyperbolas. It looks like these two branches never meet. So I'm betting we have both of our solutions over here somewhere. Now I don't know if this is going to work. Okay, so here we have the one solution intersecting at 1 comma 1, and then here's the other intersection at 1 comma negative 1, which is exactly what we saw when we did this by hand. That's pretty neat. Okay, for number 7, first let us identify what kind of shapes we're dealing with. This top equation is an ellipse. I know this because we have x squared and we have y squared, and they're both positive, but the coefficients are different. If one was positive and one was negative, that would be a hyperbola. If they were both positive, but they were both the same, like 5 and 5, that would be a circle. But if they're positive and they're different, it's an ellipse. The bottom equation is just a line. Nothing is being squared. So we're talking about an ellipse and a line, and we're looking for the points of intersection. I'm definitely going to do the substitution method for this problem as opposed to the elimination method. Whenever I have a tiny little equation and it will be easy to get one variable by itself, substitution presents itself as a good option. Whenever I do substitution, I like to write the problem side by side, so I'm going to do that now. So here I've written the two problems side by side. So the first thing I want to do is get y by itself. So adding 3 to both sides, I would have 2x plus y is equal to 3. Subtracting 2x from both sides, I would have y equals negative 2x plus 3. So now y is by itself. So what I can do is take this expression and substitute it for y in the other equation. Now it's going to go in more than one place. I'm going to put it here, but I'm also going to put it here. All right, everywhere I see a y. So I'm going to have to write small. In fact, can I get any further over? Nope, gets as far as I can go. So 5x squared plus 6 times negative 2x plus 3 squared plus 97x minus 2 times negative 2x plus 3 minus 106 equals 0. I might have to zoom in because I'm not going to have enough space. Okay, so I'm going to have 5x squared plus 6 times, and the only thing I can do is write this twice. So I'm going to have negative 2x plus 3 times negative 2x plus 3 plus 97x minus 2. And again, well, actually, I can go ahead and do the distributive property here. So scratch that. Okay, so I'm doing the distributive property right now. So that's going to give me plus 4x minus 6. And then I've got the minus 106 is equal to 0. Okay, so I've got 5x squared. I've got to multiply these two binomials together. And that's going to give me a trinomial right here. So this is going to be 4x squared. Inner I have negative 6, outer I have negative 6. So that's going to be negative 12x plus 9. That's my trinomial. Plus 97x. You know what? I might as well start combining these like terms now. So I've got 97x plus 4x. So that's 101x. Okay, so I just put these together. These are like terms as well. So that's going to be negative 112 is equal to 0. So now I have 5x squared as I go back to normal size. I'm going to distribute this 6 now. So this will be plus 24x squared minus 72x plus 54 plus 101x minus 112 is equal to 0. Like terms, I have like terms right here. So that's going to make 29x squared These numbers are not pretty. Okay, these are like terms right here. So that makes 29x if I put these together. These are like terms here. If I combine those, I get negative 58 equals 0. Now, I'm noticing that all of these are divisible by 29. All right, so I'm definitely going to take advantage of that. Okay, divide everything by 29. So that will give me x squared plus x minus 2 is equal to 0. All right, this looks factorable. So x squared is x times x. 2 is 1 times 2. If I make this negative and this positive, it'll give me a positive 1 in the middle. So I can find my solutions by setting each of these factors equal to 0. Adding 1 to both sides, I get x equals 1. Subtracting 2 from both sides, I get x equals negative 2. So I'm going to go back to the top where I begin to write my solutions. So I have 1 and negative 2. So I'm going to construct my solution set up here. So I have an x value of 1. So that means 1 comma something. And I have an x value of negative 2. So that means negative 2 comma something. So I have these x values. I just need to find the y values that go with them. Okay, 1 and negative 2, just double checking. So the way I will find the y values is by using this equation right here. All right, let's start off by letting x equal 1. All right, we're substituting this first x value so we can get the y value that goes with it. So y will equal negative 2 times 1 plus 3. So y will equal negative 2 plus 3. So y will equal 1. So that means the y value is 1. So there's one solution, 1 comma 1. Okay, now let's try the other x value, negative 2. So we will let x equal negative 2 next. So then this equation becomes y equals negative 2 times negative 2 plus 3. So that's y is equal to 4 plus 3. So y is equal to 7. Okay, so that is the y value that goes with this x value. So that gives me the solution, negative 2 comma 7. So these are my intersection points. Let's go ahead and check Desmos.com. Let's take a look at the graph and see how this ellipse and this line intersect at these 2 points. So take a look. Here you can see the part of the ellipse that I described and the line passing through it. And you can see that they have intersection points here at negative 2, 7 and 1, 1. And here I've just zoomed out so you can get a better view of the ellipse and the line intersecting at these 2 points. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.